In recent years, anti-lock brakes have become a common feature on new vehicles. Many different kinds of ABS systems, produced by a variety of manufacturers, are found on Chrysler Corporation vehicles. Keeping track of these systems can sometimes be quite a challenge. Hi, and welcome once again to MasterTech. This month, we're going to take a look at anti-lock brake systems diagnosis and repair, specifically for the Bendix Antilock 9 and Antilock 10 systems. So, with the focus on good customer relations, we're going to review the Bendix Antilock 9 and 10 Service and Diagnostic Procedures Manual. We're going to look at the diagnosis of a typical Bendix 10 problem and compare this to diagnosis of the same problem on the Bendix 9 system, and cover the repair procedures for this problem on each system. Let's begin with a look at the vehicles equipped with Bendix Antilock 9 and 10. And the Service and Diagnostic Procedures Manual, which you'll need in order to service these systems. The Bendix Antilock 9 and 10 systems are, like any ABS system, designed to prevent wheel locking tendencies during braking conditions. During anti-lock braking, both systems control the front brakes individually, while the rear brakes are controlled together. Although the basic principles are the same, the systems are somewhat different. Anti-lock 9 includes 3 isolation valves, 3 build valves, and 3 decay valves, for a total of 9 solenoid valves, hence the name Anti-lock 9. Anti-lock 10 uses an additional isolation valve, so there is one in each of the rear wheel circuits. There are other important differences between these systems as well, including diagnostics and vehicle application. The Bendix Antilock 9 system is found on 1989 to 1991 Jeep Cherokees. You'll find the Antilock 10 system on a few more models: 1990 to 1993 Dynasty, New Yorker Salon, Imperial, and New Yorker Fifth Avenue. 1991 to 93 Caravan, Voyager, and Town & Country. And 1991 to 1992 Premier and Monaco are all optionally equipped with Bendix 10 systems. Earlier this year, Chrysler Corporation published a manual specifically covering these two systems, the Bendix Antilock 9 and 10 Service and Diagnostic Procedures Manual. All service and diagnostic information for vehicles equipped with the Antilock 9 and 10 systems, except for Premier and Monaco, can be found in this manual. It supersedes all other service and diagnostic manual information and training materials previously published on these ABS systems. Since this manual is set up a little differently than both the service manual sections and diagnostic procedures manuals you're used to, let's take a few minutes to familiarize you with the format. This manual is divided into 12 sections. The first 2 sections contain introductory material, including component charts listing the locations of both diagnostic and service information for various components, and ABS applications charts. Next, you'll find description and operation information for each of the systems, followed by connector pinouts and component locations. By the way, each section in the manual contains its own table of contents to help you find information within that section. The next major section contains diagnostic procedures. The first part of the section contains Antilock 9 procedures, and the latter part is for Antilock 10. Always be sure you're in the correct section before beginning any diagnostic steps. As you'll notice when you look at the diagnostic procedures, this section does not use the flowchart diagrams you're familiar with. Rather, it uses diagnostic charts, but these are just as easy to use. Just perform the action described in the action box and answer the corresponding question either yes or no. Your next step, or a repair, will be indicated in the appropriate box. After diagnostic procedures, you'll find the maintenance and service procedures. Again, the procedures for Antilock 9 and Antilock 10 are separated, so be sure to look under the appropriate system. Section 9 is the specification section, where you'll find such things as wheel speed sensor to tone wheel gaps, service part numbers, and tightening references. If you need to reference wiring diagrams while performing service or diagnostic procedures, these are also available in the manual. You'll find wiring diagrams separated by body style in Section 10. And finally, a special tools section and acronyms can be found at the end of the manual. In the next section, we're going to take a look at a diagnostic procedure on the Antilock 10 system. But first, let's take a minute to answer this review question. True or false? The Bendix Antilock 9 and 10 Service and Diagnostic Procedures Manual should take precedence over the 1991 Bendix ABS and AW4 Transmission Systems Diagnostic Procedures Manual for Jeep. The answer is true. The Bendix Antilock 9 and 10 Service and Diagnostic Procedures Manual should supersede the ABS information in all old service, diagnostic, or training manuals. One condition you may encounter on the Bendix Antilock 10 system is a master cylinder seal leak. With this condition, the yellow ABS warning lamp and the red brake warning lamp will be illuminated. In addition, the pump motor will run continuously, or in a few cases, will cycle on and off frequently. A low accumulator fault will also be set. So, after a visual inspection, diagnosis of the problem should begin by using the DRB3 to check the system for faults. You'll need to use SuperCard CH8000 with the DRB3 for any of the vehicles equipped with Antilock 10. Checking for DTCs, we do in fact get a low accumulator fault. So, following the chart in the Antilock 10 Diagnostics section, we proceed to test 7. Remember, if any other faults are present at this point, be sure to make a note of them. Diagnosis and repair will need to be performed for each fault you encounter, and should be performed in the order in which they appear here. Test 7 is the low accumulator fault test. On the page preceding the diagnostic steps, we can find background information about the fault, including a brief description, symptoms, and possible causes. Looking at the actual diagnostic procedure, Step 1 asks if Test 1 has been performed. Remember, Test 1 was to read DTCs, so yes, we have finished this step. In Step 2, we are asked if the low fluid park brake fault was set. In this case, no other faults were set, so we answer no and move on. Following the procedure, we now press and release the brake pedal 40 times to depressurize the accumulator. The ignition should be off for this part. Once we get to 40, we turn the ignition on to find out if the pump motor is running, and we can hear that it is. So, following the diagnostic procedure, we proceed to Step 7, which asks if the pump motor quits running within 2 minutes. In this case, the answer is no. The pump motor does not shut off within 2 minutes. As the procedure instructs, we now go to Test 22. Test 22 is the hydraulic pressure performance test. Again, background information is provided on the page preceding the diagnostic procedures. Step 1 in the procedure asks if Test 1, 7, 8, 21, or 25 has been performed. Of course, we have performed both Tests 1 and 7, so we can go to Step 2, where we are instructed to connect the pressure gauge to the hydraulic assembly. The pressure gauge used for Chrysler, Plymouth, and Dodge vehicles is special tool number 6163, along with adapters 6505 and 6491A. Instructions for attaching the pressure gauge are found in Section 7.2.1 of the Service and Diagnostic Procedures Manual. Be sure the accumulator is fully depressurized before attempting to connect the pressure gauge. It may be necessary to pump the brake pedal again until significant pedal effort is felt. To install the pressure gauge, first, install adapter 6505 on the pressure gauge hose. Since we are working with high pressures, be sure to tighten the adapter to the specifications found in the Service and Diagnostic Procedures Manual. Then, thread the other adapter, special tool number 6491A, into the accumulator port on the hydraulic assembly. And again, tighten to specifications. Finally, install the pressure gauge adapter on adapter 6491A. And install the retaining clip. Now, still following step 2, we turn the ignition on and observe the pressure gauge. We'll make note of all transition points in the rate of pressure buildup. In this case, the pressure builds quickly to about 400 psi. Then it climbs more slowly to around 900 psi. At this point, the pressure build seems to stop. After several minutes, the pressure has not risen past this level, and the pump motor is still running. Using this information, we can answer the questions in the diagnostic procedure, and we find that we should proceed to step 17. In this step, we are again instructed to depressurize the hydraulic accumulator by pumping the brake pedal a minimum of 40 times with the ignition off. Now we must install the internal leakage test fixture, which is special tool number 6685. This special tool is designed to isolate the hydraulic assembly from the pump motor to determine if an internal leak is present and if the leak is in the hydraulic assembly or the pump motor. It can be used whether the pump motor shuts off or not. Instructions for installing the test fixture can be found in section 7.2.2 of the Service and Diagnostic Procedures Manual. Let's take a look at the installation procedure and see just how this special tool can help in our diagnosis. Once you've completely depressurized the hydraulic assembly, remove the hydraulic assembly wiring connector from the dual function pressure switch on the bottom of the hydraulic assembly. Then connect the test fixture connector to the connector you just removed from the dual function pressure switch. Next, locate the high pressure brake fluid hose going from the hydraulic assembly to the pump motor, and remove the tube nut from the fitting on the hydraulic assembly. Now verify that the test fixture shutoff valve is in the open position, and install the test fixture between the high pressure brake fluid line and the high pressure adapter on the hydraulic assembly. Be sure to tighten the tube nut to the proper specifications. Your next step would be to install the pressure gauge in the accumulator port, had it not been previously installed. But since it's all ready to go, let's continue with the diagnostic procedure. Turn the ignition on and let the pressure build to its highest steady point. Did the pressure build to pump motor shutoff? In this case, the pump motor did not shut off. So, following the procedure, we go to step 18, which tells us to close the shutoff valve on the test fixture. This valve isolates the pump motor from the hydraulic assembly. This time, the pressure built quickly above the steady pressure point, and the pump motor finally shut off, since the pressure tester's dual function switch is on the pump motor side. Again, step 18 asks, did the pump motor shut off? By answering yes, we find the repair for this condition, which is to replace the master cylinder piston assembly. The piston assembly is replaced using an actuator piston assembly kit, part number 4740-084 for passenger cars and 4740-086 for minivans. We'll cover this repair in detail later in the program. The Service and Diagnostic Procedures Manual also says you can replace the hydraulic assembly. However, this should only be replaced as a last resort if a piston assembly rebuild kit is not available. Authorization through the Star Center is required to replace the hydraulic assembly. See, now wasn't that easy? Using the internal leakage test fixture, we were able to isolate the leak in the master cylinder by separating the pump motor from the hydraulic assembly. Removal procedures for the pressure gauge and test fixture are found in the Service and Diagnostic Procedures Manual. Be very careful to depressurize the accumulator before removing any of the special tools. Coming up next, we're going to take a look at this same condition on the Bendix Antilock 9 system to see what some of the diagnostic differences are. But first, try another review question. In order to depressurize the accumulator, you must A, hook up the pressure gauge, B, open the relief valve on the accumulator, or C, pump the brake pedal at least 40 times with the ignition off. The answer is C. Pumping the brake pedal at least 40 times with the ignition off until strong resistance is felt in the pedal is the proper way to depressurize the accumulator. Failure to do so at the points indicated in the diagnostic procedure may cause personal injury or vehicle damage. Diagnosis of the Antilock 9 system is slightly different than diagnosis of the Antilock 10 system. One variation is that different test equipment is used when diagnosing Antilock 9. So let's take a quick look now at the diagnosis of the Antilock 9 system using the same condition we just examined on the Antilock 10 system, a master cylinder internal leak. As with Antilock 10, symptoms of this problem include illumination of the yellow ABS warning lamp and red brake warning lamp, a continuously running pump motor, and a low accumulator fault. Again, your diagnosis should begin with a visual inspection for obvious leaks or component damage. Then hook up the DRB2 or DRB3 so you can read the Bendix DTCs. You'll need to use the Jeep Eagle adapter JE1000 and cable CH7500 to hook up the DRB3 on 1989 to 1990 Cherokees. And remember, you also need to use the supercard to run the DRB3 on these vehicles. As we just mentioned, an internal leak in the master cylinder will cause a low accumulator fault, which is fault code 807. With the Antilock 9 system, you may also see the pump motor fault, fault code 812 at this time. Remember to make note of any other fault codes detected by the DRB3. The low accumulator test for the Antilock 9 system is test 10. This test is very similar to the low accumulator test we ran on the Antilock 10 system. So, after the accumulator is depressurized, the ignition is turned on, and the pump motor runs continuously. So we go to test 22. Again, the first step in test 22 asks if certain other tests have been performed. And since test 10 has been completed, we go on to step 2. As with the Antilock 10 system, we now install the pressure gauge. The pressure gauge we use this time is special tool number 6530 for Jeep Eagle vehicles, and some new adapters, which are special tool number 6868-1, 6868-2, and 6868-5. These adapters are available through Miller Special Tools. Refer to the inside back cover of your Service and Diagnostic Procedures manual for order information. In this situation, the pressure gauge with these adapters works similarly to the internal leakage test fixture. Before installing this special tool and the adapters, make sure the accumulator is completely depressurized. Then remove the pump motor outlet hose from the accumulator block inlet and install adapter 6868-2 to the pump motor outlet hose. Adapter 6868-1 is installed at the accumulator block inlet. Next, connect adapter 6868-5 between adapters 6868-1 and 6868-2. And install special tool 6530 on 6868-5. Be sure the shutoff valve on this adapter is open at this point. Once all the special tools are installed, tighten the fittings to the specifications listed in the Service and Diagnostic Procedures manual. Now, just as we did with the Antilock 10 system, turn the ignition on and make note of all transition points in the pressure build rate. Again, the pressure build is normal at first, but then the pressure stops building and the pump motor continues to run. So, following the procedure, we go to step 17. Here, we depressurize the accumulator with the ignition off. Then turn the ignition on and allow the pressure to build to its highest steady point, or until the pump motor shuts off. Since the pump motor did not shut off, we close the shutoff valve on the pressure gauge, as instructed by the procedure. Now the pressure continues to build past the previous high point, and the pump motor finally shuts off. So that brings us to the repair for our condition, which, according to the Service and Diagnostic Procedures manual, is to replace the master cylinder assembly or install the master cylinder piston kit. With the Antilock 9 system, either method of repair can be used. So you can see how similar the diagnostic procedures are between the Antilock 10 and Antilock 9 systems. Now, before we finish this month, we're going to take a detailed look at how to repair this problem, and a few others, simply by installing the new master cylinder pistons. But before we move on, try this review question. Which of these three adapters is installed to the accumulator block inlet? A. 6868-1, B. 6868-2, or C. 6868-5? The answer is A. The adapter installed to the accumulator block inlet is 6868-1. An internal leak in the master cylinder does not necessarily require replacement of the entire master cylinder assembly or hydraulic assembly. For both Antilock 9 and Antilock 10 systems, piston assembly kits have been introduced to service the piston assemblies in case of a leak or other problem. The part numbers for the actuator piston assembly kits can be found in this month's reference book. The piston assembly replacement procedure for both the Antilock 9 and Antilock 10 systems can be found in the Service and Diagnostic Procedures manual. Replacement of the piston assemblies is basically the same for both systems. We'll be performing the procedure on an Antilock 10 hydraulic assembly, noting any differences you should be aware of for Antilock 9. Step 1 is to remove the hydraulic assembly from the vehicle. Be sure to depressurize the accumulator first by pressing and releasing the brake pedal as discussed earlier. Next, secure the hydraulic assembly in a vise. Be careful not to clamp any of the electrical connectors. Remove the mounting gasket from the hydraulic assembly mounting bracket or from the dash panel. Now the black dust boot should be separated from the master cylinder housing. It may be necessary to temporarily loosen the mounting bracket. Next, place a 1/2-inch box end wrench over the lower mounting stud and loosely install a nut. The wrench should be aligned in the 10 to 11 o'clock position on the input rod bearing for the Antilock 10 hydraulic assembly. If you're working on an Antilock 9 assembly, the wrench should be in the 1 to 3 o'clock position, as seen here. With the wrench aligned properly, push against the input rod bearing so the bearing moves in about 1/4 of an inch. This will relieve the bearing load on the snap ring and allow you to rotate the snap ring so the open end faces up. Pry the snap ring out of the groove using a screwdriver. The snap ring should be discarded after removal. Now slowly release the wrench from the input rod bearing. This will allow the primary piston assembly to pop out of the actuator bore. Any fluid from the actuator bore should be caught in a suitable container. Remove the primary piston assembly by pulling slowly and keeping it as straight as possible. If the piston assembly should catch, try sliding it back into the bore a short distance, then pulling it out straight. Do not try to force the piston assembly out. Once the primary piston assembly is removed, release the hydraulic assembly from the vise and place it on the bench on a lint-free cloth, stud side down. Place a cloth over the HCU outlet ports of the unit and, while holding the cloth in place, apply regulated compressed air to the secondary outlet port to expel the secondary piston assembly from the bore. On Antilock 9 units, this part of the procedure is slightly different. Before removing the unit from the vise, use a 12mm line wrench and disconnect the secondary line from the front outboard port and position the line clear of the port, taking care not to bend the line. Then place the unit on a lint-free cloth on the bench and place a cloth over the hydraulic control unit outlet ports. On this unit, apply the regulated compressed air into the same port you just removed the secondary line from and expel the secondary piston onto the bench. In either case, both piston assemblies should now be removed. Now, before you begin installing anything, the actuator bore must be cleaned. Apply clean brake fluid to the swab provided in the kit and wipe around the entire circumference of the actuator bore, pushing any foreign particles toward the open end. After swabbing, flush the bore using clean brake fluid. Then use more of the brake fluid to lubricate the new piston assemblies, including the cup seals, white ring seals, and O-rings. Now place the hydraulic assembly back into the vise to begin installation of the new piston assemblies. Place the secondary piston, spring end first, into the opening of the actuator bore, being careful not to fold or twist the cup seals. Push the secondary piston in until the rear of the piston is flush with the bore opening. Then position the cage spring at the end of the primary piston assembly over the pin on the end of the secondary piston. Slowly push the primary piston assembly into the actuator bore. Be sure the cage spring remains over the pin of the secondary piston. In addition, be careful not to rip or twist any of the seals during installation. Remember, an internal seal leak is the problem we're trying to repair. When the piston assemblies are in as far as they'll go without much force, place a new snap ring over the master cylinder input rod bearing. In addition, the box end wrench and nut should be reinstalled in the same position as before. Then push on the piston assemblies to compress the springs so the snap ring can be installed. Secure the piston assemblies and input rod bearing using the box end wrench. The shoulder of the bearing should be in past the snap ring groove. Now position the snap ring so that one end is in the 10 o'clock position and the other end is in the 8 o'clock position. The keyway at the top of the bore should be covered. Insert the 10 o'clock end of the snap ring in the groove and, using a screwdriver, press the snap ring into the groove in a clockwise direction. When you're sure both ends are properly seated, the wrench can be released. Now all that's left is to loosen the mounting bracket and reinstall the dust boot. And place the hydraulic assembly back in the vehicle using a new mounting gasket for installation. Be sure to tighten all connections to proper specifications. So there you have it, the complete installation of new primary and secondary piston assemblies. But before you stop the tape, try this one last review question. The purpose of pushing the box end wrench against the input rod bearing is to A, relieve the force of the bearing so the primary piston can be removed. B, relieve the force on the snap ring so it can be removed. Or C, loosen the primary piston so it will pop out of the actuator bore. The answer is B. By pushing against the input rod bearing, you will relieve the force on the snap ring so it can be removed. If you recall, in our August MasterTech, we discussed Bendix Antilock's 9 and 10 systems diagnosis. We looked at the procedure used to test for internal leaks, which is performed with special tool number 6685. Since proper use of this tool is critical to prevent causing damage to components, we thought we'd review the tool installation procedure. First, note that a wire harness is included as part of this tool. This must be used in order to avoid damaging the pump motor assembly. After the hydraulic assembly has been completely depressurized by pumping the brake pedal at least 40 times with the ignition off, disconnect the wiring harness from the hydraulic assembly's dual function pressure switch. Then connect the wire harness of tool number 6685 to the test fixture's dual function pressure switch. Next, connect the hydraulic assembly wiring harness that you disconnected earlier to the wire harness of tool number 6685. The remainder of the test should be performed as described, but remember, failure to use the wire harness of special tool number 6685 will cause excessive pressure in the system and damage to pump motor components will occur. The second part of this segment concerns using the information in TSB 052494. If a vehicle equipped with a Bendix 10 ABS system is diagnosed as having a low accumulator fault, or the pump runs continuously, you may try to use this TSB to track down the cause. It's important to keep in mind, however, that the first and last part of the TSB merely lists parts which are now serviceable and the associated service procedures. Replacing these parts is not necessarily part of a repair. To track down the actual cause, you must use the internal leak test referred to on page 7 of the TSB. This is the same test we covered when discussing the wiring harness that must be connected to the test fixture. For information about running this test and for additional diagnostic information, refer to the Bendix Antilocks 9 and 10 Service and Diagnostic Procedures Manual, 81 699 94387, or see the August 1995 MasterTech.